All right, objective 2, taking the square root of perfect squares, negative numbers, and non-perfect squares. I want you to be able to master the skill of working with radicals. And so in this objective, I'm going to break it up into 3 videos. We're going to work on taking the square root of perfect squares, and then non-perfect squares and what that looks like, and then negative numbers, which turn into imaginary solutions. And the whole purpose of this is moving forward, as up until now we've only used factoring as a strategy to solve quadratic functions, and factoring leads to always real solutions for the most part. And what we did, it did. And then what we're heading into, though, is using the strategy of taking the square root to solve for quadratic functions, and then eventually using the quadratic formula to solve for quadratic functions. And this skill, simplifying radicals, is huge because you will see it in both the square root strategy and the quadratic function strategy. So you need to get really good at working with simplifying radicals before you can use the other 2 strategies that are necessary to master Module 3. So let's begin. What does it mean to take the square root of a number? I discussed this in another video as well, but let's look at it. The square root of 9, I know to be 3. Because it works out that way, because 3 squared goes back to 9. And that means that this radical here and the power of 2 are inverses each other, meaning they do the opposite thing to a number. And technically, the square root of 9 is plus or minus 3. And we talked about this earlier, but just this is a good refresher. Because the positive version of 3, which is technically 3 times 3, equals 9, and the negative version of 3 squared, which is negative 3 times negative 3, also equals 9, because a negative times a negative become a positive. That's why whenever you take the square root, you need to put plus or minus. So there's 3 types of radicals you will encounter as you start solving with the square root method and the quadratic formula. The first are perfect squares. And so with perfect squares, and this is what this video is going to be about, the solutions are what's called rational, meaning they are real numbers, they're whole numbers, and they can be positive and negative. So let's take a look. But please make note of this, because this will show up later as we talk about the discriminant of a quadratic formula. So the example, the square root of 121. I know that if you memorize your perfect squares to be 11. Now if you don't, you can always use your calculator and take it out and take the square root of whatever number exists and see if it's a perfect square. If it's a perfect square, it will break down to an even number. Now, to finalize my answer, though, I'm not done, and this would be marked incorrect on a test unless you put that the square root of 121 is plus or minus 11, because as we just discussed up here, the positive version equals that same number, and the negative version also equals the same number. And example 2 is the same thing. I would check on my calculator if I don't have the perfect squares memorized, but the square root of 49 simplifies to 7, but I need to put plus or minus 7 to finalize my answer.